Adding vectors in two dimensions. Previously, we learned about how displacement, velocity, and acceleration are vector quantities. Vectors can be added together. Let's walk through adding two displacement vectors together. First, draw the first vector, beginning at the origin with its tail at the origin. So the tip is over here. Then draw the second vector with its tail at the tip of the first vector. Finally, draw the resultant, which is the answer, from the tail of the first vector to the tip of the last vector, or in this case, the second vector. The direction of each vector matters. In this first case, the vector sum of 5 units to the east plus 2 units to the west is 3 units to the east. For instance, if the second vector had been 2 units to the east and not to the west, we get a different answer. In this second case, the vector sum of 5 units to the east plus 2 units to the east is 7 units to the east. Vectors that point in the same direction add together and create an even longer vector, while vectors that point in opposite directions subtract from each other. Remember, the magnitude of a vector refers to its length. Here's an example with numbers. 7 minus 5 is 2. But how about if the vectors are along different axes? What is the vector sum of 5 units east plus 2 units north? First, we draw the first vector, beginning at the origin. Then we draw the second vector with its tail at the tip of the first vector, but this time the green vector is pointing straight north. Finally, we draw the resultant, the answer, from the tail of the first vector to the tip of the last. The resultant vector ends up being the hypotenuse of a right triangle. Calculating the resultant vector's magnitude and direction requires the use of right triangle mathematics, trigonometry. We know the length of both sides of the triangle, A and B, but we need to know the length of the hypotenuse, C. The magnitude of the resultant is equal to the length of the vector. We get the magnitude of the resultant from the Pythagorean theorem. C squared equals A squared plus B squared. We know A is 5 and B is 2, so we plug those in, take the square root, and we get the square root of 29, which is 5.4 units. In physics, we say the direction of a vector is equal to the angle theta between a chosen axis and the resultant. With two-dimensional vectors, we can't just say the answer is positive or negative to signify east or west, or north or south, like we could do in one dimension. We will primarily use the x-axis to measure theta, though in certain situations, we will measure theta with respect to the y-axis, like that. To find the value of the angle theta, we need to use what we already know, the length of the two sides opposite and adjacent to the angle. Remember SOHCAHTOA? Tangent theta is opposite over adjacent. Tan theta is opposite over adjacent. The length of the opposite side to the angle is 2. The adjacent side has a length of 5. Therefore, tan theta is 0.4, 2/5. To find the value of theta, we must take the inverse tangent. So since the tangent of theta is 0.4, theta must be 22 degrees, taking the inverse tangent of 0.4. The resultant, or the answer, is the length and direction of this vector. This vector is 5.4 units in the direction of 22 degrees north of east.